Welcome back, everybody, to another exciting episode on quarantine chemistry. So, for today's lesson, we're gonna be looking at the Chatelier's principle, and the whole point is we're looking at how a stress causes a change in the system at equilibrium. So, when I'm referring to the stress, I'm talking about three types of stress. How does changing the concentration, okay, of the reactants change the system at equilibrium? The second thing we'll be looking at is temperature. How does temperature affect the system at equilibrium? Okay, and of course, lastly, we're looking at how does pressure, how would increasing or decreasing pressure affect the system at equilibrium? Okay, so when I'm referring to how it affects the system, I'm talking about, does it produce more products, or does it produce more reactants, or maybe nothing changes as you disrupt the system at equilibrium? Okay, so according to the Chateliers, every time you have a stress or you introduce a stress into a reaction, there's going to be a change, and then what's going to end up happening is the system's going to adjust to reduce that stress. Okay, so let's take a look at these three scenarios here. Okay, so the first one is going to be concentration. Okay, so I'm going to use a very simple example. Let's say you have two reactants, A and B. Notice the double arrow, which means yes, it is reversible. So we have to make sure we understand that it can either you can have more products or more reactants at the end, okay, or maybe the same amount. The product's going to be C and D. Okay, so let's say I decided to add more A, okay, and we're going to say, hey, you know what, this reaction is at equilibrium, which means, again, reactants and products should not be, it's constant, it's not changing after that, okay? So let's say I decide to add more of A. I decide to add, increase the concentration of A after we reach equilibrium. So what's going to happen here? So think about this, right? There's a stress on the left side of the equation because you add more of A. So according to the Chatelier's principle, the system has to adjust. So it has to shift where? Away from the stress. So if we know the stress is coming from the left side, the reaction is going to shift to the right. So I'll put this. It's going to shift right. So when it shifts right, what's going to happen to C and D? C and D, or the concentration of C and D, will increase, right? As you add more of A to the system, C and D will be produced. And then for B, you could probably guess that it's going to decrease because it's being consumed by A. Okay, so let's say you decided to, I don't know, why don't we say, hey, what do we take away? What do we decide to take away C, right? So again, different scenario. Let's say the reaction has reached equilibrium. Now you decide to decrease the concentration of C. Well, what's going to happen? Okay, so once you notice, realize there's a stress which is coming from the right side this time because we're taking away C. Again, the system has to shift in a way to make sure it goes back to equilibrium. So now it's actually going to shift. We guess it will shift to the right. Okay, and why? Just think about it this way: since there's there's less stuff, on the right side, right? Once the reaction shifts to the right, then which means it should bring up the concentration of C and D, making it go back to normal as it was before. Okay, so rule of thumb is this: when we're dealing with concentration, if the reactant or product is added, the system shifts away from the added side. Okay, if you take away or you remove the reactant or product, the system will shift towards the remove side. Okay, just want to keep that in mind when we're dealing with concentration. Okay, Okay, let's take a look at the second factor this time. Okay, temperature. Notice this time I have my same equation, but notice there's a 25 kilojoules on the right side. So what does that mean? Okay, keep in mind kJ is kilojoules. It just means heat is on. It's being released this time. So you can say this is an exothermic. Excuse me, exothermic reaction. Let me just erase that. And let me just make this. So this is again. This is exothermic. Okay, so again, heat's being released according to this reaction here. So if it's on the left side, it means it's an endothermic reaction where this reaction requires heat for it to produce the products. Okay, so make sure you identify that. All right, so let's say this. Let's say I decide to add, let's say I added, here's a scenario. So after, once the system has reached equilibrium, I decided to add more heat, right? Okay. Okay. So what's going to happen this time? Where's the stress coming from? Again, notice the heat is on the right side, 25 kilojoules. So you add heat. Where's the stress coming from? It's coming from the right side. So this reaction or the system has to shift to the left. Or excuse me. So I'll play this. Okay, shifts. I'll put shifts left. Okay, so add heat. The reaction or system's going to shift left. So now you can say what's going to happen to A and B. You can say A and B will increase. Okay, so why would it increase as you're heating it? Just think of the heat on the right side. It's going to consume C and D. As C and D is being consumed, you're going to be forming more A and B. Okay, so that's for temperature. So the rule of thumb is this. As you increase temperature, just imagine you're increasing the energy here. Okay, it's going to shift away from the energy side. Okay, notice again the energy or the heat's on the right side, so it's going to shift away from it because the stress is on the right side. Now, if you decide to decrease the temperature, different story. Now you're decreasing energy, so which means it's going to shift towards the energy side. Okay, a way to think about this is just treat heat as if it's a substance, just like as you see it for concentration there. Okay, last one. So this is the last factor, the third factor, and we're going to be looking at pressure now. Okay, this time around, we're going to be using a reaction here, a real reaction. An equation, you have N2 gas plus H2 gas yields NH3, which is ammonia. Okay, it's very similar to the last one that we saw in the previous video. Okay, so I'm going to draw this out for you. Okay, on the left side, you have 1 mole of N2 and you have 3 moles of H2. So I'm going to draw this out for you. So let's say the N2 is the filled in circle. The light one is going to be my H2. Okay. Now on the right side, you have how many moles of NH3? You have 2 moles. So I'm going to draw 2 circles. Okay. So they're going to represent the number of molecules. Okay. So let's say I decide to do this. I'm going to go ahead and decrease the volume. So let's say this. Obviously decrease volume here, right? Okay, just think back. Let's say you keep the temperature constant. Let's say it's at, I don't know, 75 degrees Celsius. Okay, so just think back of Boyle's law. As you decrease volume, what's going to happen to pressure? Pressure is going to increase. Okay, so if you increase pressure, so imagine when you're increasing pressure, you're actually increasing pressure to the whole system. So in other words, you're increasing pressure to both the reactant side and the product side. Okay, so it's not the same as if you're increasing heat to one side or you're increasing concentration to another side. Okay, we're actually doing it to both sides. So what's going to happen here? So which means, hey, guess what? The stress is coming from both sides, right? And in order to alleviate or decrease the stress or go away from the stress, the system has to shift away from the side with more molecules. Okay, so which side has more molecules? It's going to be which side? The left side. Okay, so which means the reaction has to shift. It's going to shift to the right side. Shifts right. Right? Because the more molecules you have, right, the more pressure you have. So which means on the left side, more molecules will shift to the right side, causing it to decrease in that pressure there. Okay, because there's more molecules on the left side. Rule of thumb is, here it is, increase in volume. Again, you're decreasing pressure. The system shifts toward the side with more molecules. Okay, so think of the opposite. If you decrease volume, you're going to increase pressure, so which means the system shifts away from the side with more molecules. That's what you saw from the example above. Okay, so what happens if you have the same amount of molecules, moles on both sides? If you have that, you're going to say there will be no shift to this reaction here because you both have the same amount of molecules on each side. Okay, so that's it. Okay, let's kind of recap. There are 3 stresses that you can introduce to a system or a reaction: concentration of products and reactants, temperature, and pressure. So when you introduce one of these stress, then the system at equilibrium has to adjust in a way to reduce that stress. Okay, so when we're talking about the adjusting, either the reaction shifts to the right or to the left, or maybe sometimes nothing would happen. And when it shifts, it's going to cause either the products or reactants to go up in concentration.